Okay, so we have went into the PhET lab and we've done two things so far. We have built simple atoms, and then just recently we decided to take it up a notch and we did building molecules, and now we're going to go a little bit further and talk about isotopes a little bit and atomic mass. And that'll complete the picture for our atoms and all the particles that we've learned about: electrons, protons, neutrons, the number that's supposed to be their negative charge, the mass, where mass from everything comes from. And so this is going to be a helpful lab to tie it all together. So on Google Classroom, we have isotopes and atomic mass, the PhET lab. And you get there by going to Clever, and you can go to my class and find the PhET lab. Now here's the instructions, and there will be a video attached here, which is what I'm making now. And it says, use the attached slide deck to organize the isotopes we build in the PhET virtual lab. There will be 6 different screenshots that you will transfer, 1 screenshot per slide, and a data table to fill out chronologically throughout the slide deck. And so this is what the slide deck looks like. And you're going to put your name here. And here's the kind of directions on how the first one works. There's isotopes and there's a mixture. We'll be doing both. And here's the data table. So all the missing boxes are what you're going to be finding, and then you're doing screenshots of each one of them. So for instance, number 3 is an oxygen. So in this, you would have a screenshot from the PhET lab of oxygen as you build it. But before we get into the PhET lab, let's go through a little simulation that talks about isotopes in general and how they're found in nature, because that's going to be part of the lab questioning. So the question for this right now is, what would happen to a person's mass if the composition of isotopes on Earth changed? So let's just play this simulation. So a human body weighing 70 kilograms or 154 pounds is made up of over that many atoms. I don't even know that number. We should look it up. Of these atoms, 99% are either hydrogen, oxygen, carbon, or nitrogen. The remaining 1% of atoms come from 31 trace elements. For example, carbon is a mixture of carbon atoms weighing 12U and 13U. So if you were to put those on the scale, obviously the 13U weighs just a little more. The nucleus of a carbon atom always contains 6 protons. Its atomic number is 6. However, the number of neutrons varies. Sometimes the nucleus contains 6, and sometimes it contains 7. Atoms of the same element that contain different number of neutrons are called isotopes. In nature, elements occur as a mixture of their isotopes. However, it's not an even mixture. Some isotopes are found more commonly than others in nature. In the case of carbon, you're almost 100 times more likely to find a carbon-12 atom than a carbon-13 atom in nature. What would happen to a person's mass if the average mixture of carbon isotopes on Earth changed? What about hydrogen or nitrogen? So basically, our weights would differ because a carbon-13 atom definitely has more mass to it than the carbon-12 atom. And this simulation right here just kind of shows the math. If you have a mixture of 98% carbon-12 atoms, and you added those together with the 2% of carbon-13 atoms, this is how they calculate the average atomic mass. So on our periodic table, that's where they get the 12.02 for that mass. So now let's go to the lab. We're at the lab, and according to our slide deck, we're going to be filling this chart out right here, so I'll do one as an example. The information I have is carbon-13. So I'm going to go over here, click carbon. It's going to give me a stable carbon-12 atom. I need a 13. So in order to do that, I'm going to add a proton. And it gives me carbon-13. I'm going to open up these boxes, and you can see that this particular isotope is kind of what they were saying with that other simulation. It's the more rare isotope in nature, 13.07%. We'll take that neutron away. We're back to carbon-12 stable, and this is the one that they said was 98%. This is the one that's in nature most often, carbon-12. Okay, so we need the carbon-13 for our purposes, and our table shows that we need to get the symbol for that, so this is going to be a snipping tool situation. So we do new, get the symbol right here, copy over since we're going to slides, and we can paste, resize it so it fits in there, like so. And now we can fill out the rest of the table. So we know that protons in a carbon atom, since the mass right now, we can even count them, or we can just look at the atomic number, which is 6. We know that there's 6, so we're going to go back, put 6 there. We know that there's 7 neutrons. We also know that the amount of electrons are equal to the protons. We learned that previously. See the chart right here, just make sure 1, 2, 3, 4, 5, 6. So we can go back to that. The atomic mass will be right here. So we can put 13.00335. So let me copy that. 00335. Abundance of this in nature is right here, 1.07%. And is it stable or unstable? And in order to find that out, we look right here and it says stable, so put that in my chart as well. Stable. And then I'm just going to get a screenshot and put it right here for isotope number 1. Go back, make sure both these tables are open. Snipping tool right here. And that. Copy. Go back to our slide deck. Paste. Control V to paste. Resize. And we're good to go. And we'll just keep doing that for the rest of the isotopes. And then part 2 right here is going to be a separate video. Once we get to that, we'll do this final video for that. But that's it for this. Our goal is to fill out this table with the information that they've given us. And that will be the lab for isotopes. I'll be around to answer questions live. I'll see you back in class.